morning, everyone. Assalamu alaikum. This is Dr. Qusay with you, and I'm going to continue our lecture regarding the computer architecture's design. The last lecture was regarding how to multiply hardware version 1 and version 2. Similar way, today we are going to talk about the divisor, how to dividing hardware, how to design dividing hardware for version 1 and version 2 for ALU, arithmetic logic unit. Before we go for divisor, let me just revise and let we do some just dividing, just divide two number. First of all, let's go through abbreviation. So the abbreviation of this one, we call it dividend. So just you have to memorize this. We call it dividend, and this one we call it divisor, and this one we call it quotient. This one we call it quotient. Now everything here we call it remainder. Okay, this we call it remainder. So we have divisor here, divisor, dividend, and quotient and remainder here. So just let we do the normal division for decimal number. Just let we see decimal number. Let we say, for example, 128 divided by 8. So actually what we do, we are going to put 1 divided by 8 cannot be. So if it cannot be, so we are going to put 0, and then we are going to take two numbers, which is 12. 12 divided by 8, it have 1. Okay, so this is 1 times 8, this is 8, and the 12 minus 8 is 4. Okay, then we put the other one, which is 8. 48 divided by 8, it have 6, so we are going to put in quotient 6. 6 times 8 is 48, and this is 0. That's a normal decimal number. Now what about binary? Binary is 0 and 1. So now first of all we are going to divide 1, 1, 0. So this is cannot be. So we are going to put 0, and we take the second number. 1, 0 divided by 1, 1, 0 also cannot be. We are going to put another 0, and we are going to take the third number. So third number is 1, 0, 1, 0 also cannot be. So we are going to take the fourth number. So it will be 1, 0, 1, 0. This is 10, equivalent to 10. So 1, 0, 1, 0 divided by 1, 1, 0, it have a 1. Okay, so if you put 1 and put 1, 1, 0, this is remainder side, by the way. This is remainder side. So 1, 1, 0, and we do subtraction. So this is 0 minus 0 is 0, and 1 minus 1 also 0, and then after that, so this is 0, 0, and 0 minus 1 cannot be. 0 minus 1 cannot be. So what we have, we are going to borrow 1 from here. So this is 2. 2 minus 1 is 1. Okay, so it's 1, 0, 0. 1, 0, 0 is, it should be less, or it should be bigger or equal than 1, 1, 0. Is it bigger or equal than 1, 1, 0? No, 1, 0, 0 is 4, and 1, 1, 0 is 6. So is it smaller? So what we are going to take, we are going to take the last one from the dividend, just put it down. So it will be 1, 0, 0, 1, and you are going to minus it from 1, 1, 0. So it will be 1, 1, 0. So 1, 1, 0. So it need, this is, you put 1 here. So this is 1, 1, 0. So it's finished. There is no remainder in this one. In this case, the remainder is 0 for this one. However, 0, 0, 0 from the left sides, all of you, any number, any 0 on left side, it will not consider. This is 0. So the results of the dividend divided by the divisor give you quotient of 1, 1, 1. That's how we consider. The 0, 0, 0, 0 on the left count as a nothing. So we don't care about the 0 on the left. So this number divided by the divisor, it will give you the quotient of 1, 1, 1. We don't care about the 3 zeros because on the left. So what is the procedure here? Let me take another example for the division. Let me say we have here 1 0 0 1 0 1 0. This is dividend, and we have the divisor. This is in decimal. This one is 8 in decimal. Okay, so what we have, first of all, we have a 1 divided by this cannot be, so this should be 0, and we take the second one. Second one is 1 0 divided by this one cannot be. We are going to put on the quotient another 0, and we are going to take the third number, and so on, until we reach to 1001. Okay, 1001, is it equal or bigger than the divisor? So should be equal or bigger than divisor? Yes, as long as bigger than the divisor. So this is, we are going to put 1 in the quotient. This is always the procedure. We are going to put 1 in the quotient, and then we are going to do subtracting. When you do subtracting, there is 1 left, and then you put 0 here. So 1 0, you put 0 from the dividend. So 1 0, is it small? Is it bigger or equal than this? No. So you are going to put 0 here. See here, we are going to put 0 in the quotient because we are going to take another number which is 1. So 101, is it bigger or equal to this one? No. As long as not bigger or equal, so I am going to put another 0. So here, see here, this has become 100, and I am going to put the 0 down. So this is 1010. Is it equal or bigger than this? Yes, it's bigger actually. So I am going to put 1 on the top, and then I'm going to 1 times this one is 1000, and you do subtraction. There is 1 0 left, which is 2. So is there any more than this in divided? No, there is no more than this in divided. So what we are going to say? We are going to say the quotient is 1001, and there is a remainder of 10 of 10, which is 2. The remainder is 2. However, now if you watch how the division working out, actually you are going to compare the dividend with the divisor. So the condition to do to put results, to put 1 or 0 in the quotient, so it should be dividend should be the condition dividend should be equal or bigger than the divisor. Okay, if it's smaller, so we should put 0 on the quotient, okay, and we take 1 from the dividend. So the dividend, how we are going to take 1? We are going to shift toward the left. So here, see here, in this direction, when you go from this to this, you are going to take this, then you are going to put this one down, then you are going to move to the left. So this is left register, shift left register. For the quotient, so you are going to put 1, then after that you are going to move to the right and put the second number. Move to the right, so you are going to shift it to the right and put the third number. Shift it to the right, put the fourth number. So this we call it shift right register, and the new number which you are going to put it will be the lower significant bit. So this is the most significant bit. The new number which you are going to put it is the lower significant bit. All this area we name it remainder register. So we have 4 register actually. We have dividend, which is going to move toward the right, so it's shift right register. We have the content is going to move to the left, so it's shift left register, and the last bit which you are going to put it, we call it least significant bit. The first bit which you put it already is most significant bit. Okay, and we have this register we call the remainder register. So we have 4 registers. Now let's go for hardware division for hardware division 1 hardware divide hardware version 1. As you see here, this is the divisor shifted to the left, so this is divisor. This is exactly same design for multiplication, but see here, this is, we call it, see here, that's the difference. This is, we are going to put the divisor here, okay, and you are going to put the quotient here, okay, and we are going to put, so this is the divisor, this is the quotient, okay, and you are going to put the dividend here in the arithmetic logic unit. You are going to put the dividend here in the remainder. You are going to put the dividend again. You are going to put the dividend here in the remainder. Okay, and you do you see how much you have in the remainder, and then you compare it with the divisor. Okay, if the remainder have equal or bigger than the number in divisor, so it's going to put 1 in the quotation. So quotation is going to shift toward to the right. See here, the quotation is going to shift toward to the right. So 100 shifted to the right, and you put 1. So that's, and then you subtract the remainder from the divisor. You subtract the remainder from the divisor. Okay, so that's for hardware version 1. It's similar like for the multiplying hardware version 1, same design. So you have here 64-bit for the divisor, 64-bit for remainder, and 64-bit for arithmetic logic unit, which is actually expensive when you are going to design it. So here, see here, you are subtract. So we are going to follow the flow chart. You find it exactly same as I mentioned, just same operation. So first of all, you are subtracting the divisor from the remainder. So we are going to subtract the divisor from the remainder registers, and then we are going to check if the remainder bigger or equal. Then after you subtract, you are going to put a number from the remainder. You are going to put a number from the remainder, and you are going to compare it. If it's bigger or equal than 0, actually not bigger or equal, it is bigger or equal than the divisor. Okay, if it's bigger or equal than the divisor, so you are going to shift the quotation from the toward to the left. So quotient, you are going to shift it toward to the left. You put 1 here, and then you are going to subtract the remainder from the divisor. Okay, so if it's less than 0, if the remainder less than 0, so you are going to restore the original value of by adding the divisor register to the remainder. Okay, and place the new number for the remainder. Then after that, you are going to shift. By the way, at the end, you are going to put 0 on the lower significant bit, same like when we saw here. So if it's less, we are going to put another number in the remainder. Okay, so we are going to shift the remainder to the right, put number in the remainder. Okay, and put 0 in the quotient. You put 0 top on the quotient. Okay, and then here you have to put another 0 on the top of the quotient to put this one, the other bit from the dividend down. So and then until you compare is bigger or equal. But this operation will continue this operation until you reach 33rd bit. Why? Because here, as you see here, is 32 bit. Until you reach 33rd bit. If you reach 33rd bit, okay, that means you have finished all the number, all the divided number. That's it. There is no more divided number. So you are going to check how much remainder you have and what is the quotient. So you say the quotient is that number and you have remainder. If the remainder is 0, that means it's no remainder. So if the remainder it have number, so that means you have remainder. Okay, at the end. So that means done. For hardware version 2, as you see here, as I explained, same like multiplying hardware version 1 and multiplying hardware version 2, same, exactly same idea for divider hardware version 1 and divider hardware version 2. Now here you have 64-bit for divisor and 64-bit for arithmetic logic unit. For hardware version 2, for cheaper, you are going to do the operation where you are going to do it now here in version 1 we are going to do it in divisor. Okay, for hardware version 2, no, the operation is going to be done in the remainder. Okay, now here the subtraction, all the subtraction is going to compare with the divisor and you are going to do it inside the divisor. Okay, the operation. For hardware version 2, the division for hardware version 2, you are going to do it inside the inside the remainder. And for cheaper process, so the divisor is just put it 32-bit and arithmetic logic unit is very expensive, very expensive to take 64-bit. So you are going to go for 32 bits, and this is going to be much cheaper, less cost. Okay, and same you see same design, but just the different in see here, this is the design, exactly same design. The different we are going to change the divisor register to 32-bit, the arithmetic logic unit to 32-bit, and the operation is going to be done inside the remainder. Okay, the remainder is 64-bit, so it will be, is going to put all the results from the dividend here. Sorry, we are going to put it here and we are going to shift it to the right. So we are going to do shift right. There is no shift left here. Do shift right, and every time you do want. So every time you do shift right, you are going to put 0 in the quotient, unless you compare the divisor with the remainder. If it's equal or bigger than 0, if it's equal or bigger than the divisor, so you are going to do subtraction and put 1 in the quotient. So that's briefly how you do it until this is would continue until is bigger than the 32-bit. The register is bigger than 32 bits. When it's bigger than 32 bits, so if it's equal to that 32 bit, that means you reach to the end. Bigger than 32 bit, that means that's the end. It's finished. Or when you reach to 33 bits, that means it's finished. Okay, finish and is done the operation. So that's it for today lecture. Is exactly same like hardware, multiplying hardware for version 1 and 2, but this is for the division. Thank you for listening. Good luck to all. Bye.